Hello everyone. We are at Everglades Research and Education Center, a designated site for organic soil research in South Florida.
In South Florida, we not only have the pretty beaches, we also have the very important agriculture area. It's called the Everglades Area. So here it contributes over half of the U.S. sugar production.
Today we will interview Dr. Jehangir Bhadha and we will try to understand and know his research program, how he is doing research in Florida Aquatic PBL. Thank you. Good afternoon everyone from University of Florida. I am MD Anik Mahmood, a PhD student of University of Florida.
Hi everyone, my name is Xuebai. I'm a PhD candidate to work on soil, water, and nutrient management. I'm the co-host today.
Today we are doing podcast arranged and funded by STEPS. The objective of the podcast is to spread and share our knowledge to common people about what kind of research we are doing in University of Florida, particularly in South Florida. Today we are excited that we are having Dr. Jehangir Bhadha from University of Florida. And I want to give a short introduction of what kind of research Jehangir Bhadha is doing in University of Florida. He's an associate professor in soil, water, and ecosystem sciences in University of Florida, and he's stationed in Everglades Research and Education Center. His research and extension work promotes sustainable agriculture in South Florida and beyond. Dr. Bhadha earned his PhD in soil and water sciences from UF in 2009, following his degrees in geology and hydrology. So, welcome, Dr. Jehangir Bhadha.
Thank you very much, Anik and Shua, for hosting this blog for STEPS.
We're gonna ask Dr. Jehangir Bhadha about his research and what kind. First, I want to ask him about his research related to. Can you give us a brief summary of your research? What do you do in South Florida?
Sure. My research and extension program deals with promoting sustainable agriculture in the state and beyond, nationally and even internationally. I use a integrated approach, integrating soil health and sustainability with water resource and water quality. And the third foundation is nutrient management. So I use soil, water, and nutrient management as an integrated approach to promote sustainable agriculture in the region.
So how long have you worked on the sustainable agriculture?
Sure. Well, I want to say it's been right after I received my PhD degree in soil and water sciences. I wanted to focus more on applied research, to do hands-on work and to be able to see the change in the community, in the public. And that's when sustainable agriculture seemed like a really good avenue for me to express my research and conduct outreach efforts.
Yeah. So that's been a long time. So we are curious about what makes you initially what inspired you on this research? Why you choose your the major? Why you choose this one?
I always liked being outdoors. I was an outdoor person. You couldn't keep me in a classroom for too long. So anything that had to do with field work or an excursion or camping, I was attracted to those type of settings. And so it was only very natural that a field like agriculture, water resources was very attractive to me because it allowed me to be outdoors. If you also think about it, with applied research, there is so much you can do in the lab. There's so much you can learn in classrooms and libraries. But after a point, you have to want to kind of put that knowledge out to the public and see its impacts and see its effects. So that has always been an attraction for me.
We all but know the South Florida is a unique area and it has a unique environment. What do you think your research fit in the South Florida, and is the unique environment helping you in your research, in your aim overall?
Yeah, definitely. I would agree with you that South Florida is a unique ecosystem. And when I say unique, I also want to add it in context with phosphorus sustainability. We are located in a subtropical type of a climatic system. Here in the Everglades Agricultural Area, our soils make us extremely unique. We work with histosols. These are highly organic soil types, very rare, and so those are unique to our South Florida systems. What is also unique is that we have had a history of working in the space of nutrient management, particularly phosphorus. So this is not something that I just came in and decided to work on. It's been studied, it's being researched for many decades, and we are kind of building on that very strong foundation that this South Florida provides us. What also makes it unique is that we are not just South Florida is not just a single, or I should say, a mono land use, right? It's not just farming. It's a very dynamic system. It's got farming, it's got urban sprawl along the coastline. It's also got freshwater systems. It's got saltwater intracoastals and the coastline as well. So a very unique hydrograph, very unique climatic condition, soil type, rainfall and weather patterns, and a history of phosphorus research. So that really makes South Florida unique.
Yeah, sound interesting. Yeah.
So, what do you think is the main issue of the phosphorus happened in the South Florida?
Sure. Well, like I said, it has a history. South Florida has had a history of phosphorus work and research, and it probably dates back many decades to when phosphorus was identified as a limiting nutrient in our ecosystems. And what I mean by a limiting nutrient is the fact that any changes in phosphorus levels or phosphorus concentrations can impact the ecosystem, can impact the fragile system within South Florida. Once phosphorus was identified, there was clearly a need to work towards trying to maintain and optimize the use of phosphorus in farming, in urban areas, and its input into our water systems.
Can you give us some interesting topic in your program that you are doing related to Florida's problem that you have just described?
Sure. So one of the interesting aspect about, I would say, working or doing research or farming in South Florida is its soils, histosols. We have been dealing with a situation which we commonly refer to as soil subsidence. What this means is our organic soils, which have almost 70 to 80% organic matter, we are losing that organic matter simply to the atmosphere as CO2. Over the last 100 years, we've lost nearly 6 feet of our soil. And in certain areas, we have extremely shallow soils, only a few inches of soils to farm with. So, one of the interesting aspects of my program is finding ways so that we can sustain these soils and continue to stay in farming and in production, hopefully for the next century.
And Are you seeing in near future that your research can help the growers, the stakeholders in South Florida can get benefit from? And can you give us some example of it?
Sure. So how are we working towards combating this soil subsidence? One of the ways is application and adoption of cover crops. You see, USDA NRCS has done really good work in putting out the foundation and benefits of cover cropping. Having live roots in your soils helps us to sustain good soil health and also the longevity of our soil. So during the summer period, one of the good practices would be to apply some cover crops and manage some cover crops on your field rather than keeping those histosols fallow. Another way to slow down oxidation is to keep your soils hydrated. So, keeping the soils flooded, or as a lot of the growers in the region are doing, cultivating flooded rice in the region on the muck soils, on our histosols, is a good practice to slow down oxidation and maintain these soils. I would say these two practices are definitely beneficial for our growers. To a smaller extent, I would say the application of organic amendments, organic feedstock back into the system are also great practices that can help with the longevity of our histosols in the region.
It is very interesting that you are finding this solution and also sharing this information to the stakeholders. We have heard that in South Florida, especially in the winter, you have winter fair, and we all in the South, especially the Iraq, they show their research to the common audience what they are doing. And my question is, this very important information, where they can get this information, this that from your research, these findings, where they can get these informations.
Sure. So I have a research responsibility, and I also have an extension and outreach responsibility. And as a lot of my students, while I am mentoring and training them to be great scientists and researchers, I also ensure that they get some practice, some experience in outreach and extension. You mentioned the South Florida Fair. I mean, I would say that is one of our main events that we organize or help organize and represent. It is usually every January for 3 weekends and up to 17 days, where we have a presence at the South Florida Fair. I remember 15 years ago, we were represented at one table and with one volunteer present there. And that has today grown into us having our own booth and over 20 volunteers that rotate on a daily basis, and we have a presence throughout the fair. Uh, these outreach and extension events are really, really important because what they do is they help us break down the complex science into a language that even a 10-year-old child can understand. And I think that is very, very important that researchers and scientists have the ability to to explain that science to their different stakeholders, their different folks that they interact with.
So as you mentioned, you use different ways like the cover crops, the crop rotation to address the sustainable agriculture things in the South Florida. So have you used the innovative techniques combined with those techniques on your research?
Yeah, I think innovation and innovative techniques can be explored at different levels. With any research, what we would like to do first is test it at a small scale, maybe in the lab, maybe at a benchtop scale in petri dishes and things like that. If things look promising there, we might take it at a mesocosm type of a level where we might conduct some experiments, some trials in greenhouses or on a 20 foot by 20 foot field patch. And if that shows promises, then we can go up to a field scale and try to test our innovation in commercial fields, under commercial settings, in real field conditions. So at every stage, there is potential for innovation, trying something new, experimenting. Uh, I'll be the first to say that not all of it works. As a matter of fact, most of it doesn't work at different scales and different as you try to upscale things to the real world. But that is part of research, and so we have to be mindful. We have to be taking baby steps when we think about innovation, and not go all in and expect things to change in one go.
So can you give us an example, like what techniques you have used? Just an example.
Sure. So, as I mentioned, historically, rice has been grown in the Everglades Agricultural Area since the 70s. But historically, it was always farmed as a means to keep the fields flooded, keep the soil hydrated, slow down that oxidation. When we started to look at flooded rice systems, we said, hold on, is there a potential for using flooded rice as a treatment technology to improve water quality within the system as well? 25,000 acres of flooded rice is grown in the summertime in South Florida. So it was interesting for us to step in to say, what is the impact of flooded rice on water quality? Yes, it is slowing down oxidation. Yes, it's helping with soil conservation. But how about water quality? And so we've invested almost a decade into this field, trying to do research to see what its impacts are on water quality, between water coming into the rice field and water exiting rice fields, and it has been promising. Why do I say that work research has been promising, and the growers are starting to relate to that? Is because we do not apply any nitrogen, phosphorus, potassium as starter fertilizers to cultivate rice in the region. Rice simply uses the nutrients in the soils and from the irrigation water to grow. This is very unique. This is unlike any other rice cultivation systems in the world. And so it made us think as a great hypothesis that if no NPK is applied on flooded rice in the EAA, then it is potentially acting as a bio filter to filter out some of the nutrients. And that really plays a good role with water quality issues here in the EAA.
Yeah, that sounds very interesting. And so, talking about the techniques, like the AI right now is a hot topic. Everywhere, every field, they are talking about the AI. So, what do you think how AI can help the agriculture in the future?
Yeah. So artificial intelligence, I'll be the first to say that I'm not an expert on this topic. But at the same time, I don't think we should be ignoring this really, really exciting avenue that we have, especially the younger generation should embrace it. In my limited experience with AI, what I have found is that it really allows us to improve our modeling and predictive capabilities. because if you can provide your data, a lot of your data, which folks would like to call big data, to AI specialists, they can start to look at problems and issues from very different perspectives that we as mechanistic modelers have approached it. And I think that is an untapped area. So I am very optimistic about AI in the field of agriculture. You know, I am surprised but happy to know that even our growers are very open to some of the AI tools that are out there. They are open to learning about it. They are open to understanding about it. They are even open to collaborations if we want to do some sort of a collaborative effort with them in the future.
So we are in the now we are in a crossroad. We are seeing the climate is getting changed. Everything is getting unpredictable. Do I think AI and all its ability it can help us for solving problem and modeling and all the thing?
To be determined. It is to be determined. I don't know if we are there yet, but what we do know for a fact, we do know that our summers are not what they used to be. Historically, South Florida used to get 52 inches of rain in the summer months over the 4 or 5 months wet period. Now we still do get the 50 inches, but it is not just during the summer months. Our rains are unpredictable. The not just in time, but even in volume. Storms and events, hurricane events are recurring a lot more and impacting weather patterns a lot more. So yeah, these are all changing climates that we have to work with. Uh, how AI will help us is to be determined.
Actually, I want to add one more question. Yeah, since we already talked about the AI, so do you think as more people they are pursuing the career in the AI, maybe in the future the AI agriculture, do you think it will compete with scientists who are doing the fundamental research? For example, from the funding, it's hard for the traditional researchers to get the funding.
Yeah, I don't think it will be a competition, so to speak. I think scientists and researchers are some of the brightest individuals, and so they will figure out a way to adapt to this change. Um, so and they are only going to use this to help and benefit their programs, their research. I don't think it will be either or type of a situation. I think it will be together type of a scenario, and that can only be doing better things a lot faster, hopefully. And because clearly there are some areas where we can use some of these sort of tools. Just to give you an example, right now in the field of phosphorus sustainability, we do not have a very precise tool that can measure phosphorus concentrations in situ, in real time, in the field, right? So we always have to depend on collecting a soil sample or a water sample in the field, bringing it to the lab, testing it, and at the earliest you would probably have a data in an hour or a few hours. Uh, and so if we can use AI and some of these techniques to help us measure real time phosphorus concentrations in the field, that would be a game changer. So I think there are researchers and scientists right now as we speak trying to test these techniques, fine tune these techniques, and bring it to the market.
So I know in your research you have been using the different sensors, the monitoring device in the field. So do you know, like, is the farmers they currently also use some sensors in their farms?
Yes, yes. It has always been um, validating any instrument or technique, sensors for that matter, validating it has always been with the help of growers. Uh, and so there are a lot of growers who are right now, they have soil moisture sensors that are placed in their field, and they can pick up their mobile phones sitting on their office chair. They can see what is the moisture content on their sites, on their plots, and if they feel that they are below the threshold, they can call the farm managers and they can have them go and turn on the pumps and irrigate. So this has all been possible because of technology, because of sensors that are out there in the field. So from moisture, water point of view, I think it has really moved leaps and bounds research. I think from nutritional point of view, there is still a lot of potential to catch up, and 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 that'll really help us optimize our use of nutrients, optimize our use of phosphorus, which will be savings in the form of money, but also improved environmental effects.
So were there any moments makes you feel like, oh, my research really helps to improve the environment or helps the farmers to reach their farm productivity?
Yeah, yeah. I think there are definitely moments where it makes just coming into work every day worth it. One of those moments I would say is interacting with not just farmers but with school children. We do a lot of outreach with local school kids. We go visit their classrooms, provide them information about sustainable farming. And a lot of times that they have to prepare a project or they have to prepare a report. And we get to read those reports, we get to see what those kids do. These are second, third, fourth grade kids, so very young, but it is always exciting to see uh, how they are thinking about farming, and how they are including technology and sensors, and some of the new age type of farming tools in their thought process. Uh, so yeah, those are the times when it all makes things worth it. When I see PhD students graduate and get their degrees, that makes moments very gratifying as well. And even shaking hands with a grower out in their field, talking to them, understanding their systems, is also extremely gratifying. Yeah, but it is important for us to understand that, it is not very easy for farmers to adopt to something new very quickly. They always like to try it out for a few seasons. And if it is working, if it is improving the environment, if it is benefiting their bottom line, their cost, they will definitely be adopting it.
So, how do you envision the future of farming in South Florida, depending on the challenges we are facing?
Yeah, I'm very optimistic. I'm very optimistic about farming future in South Florida. Uh, I remember when I first joined the Everglades Research Center 15 years ago, and at that time people would ask me, In how many years are we going to lose these muck soils, and how many more years have we got in farming? And I said, I wish I knew. I don't have the answer, but we've come 15 years. We are still in farming. I think the growers, the farmers have adopted to change. We as researchers have been making some breakthroughs in areas. The communication lines are open, so we are translating our science and conveying it to them. The growers walk up to our office doors with a problem and tell us about it, so we can explore that, investigate that better. And to be honest, funding has also been pretty good, at least in the last few years. So it has provided us with the resources to do the research to answer the questions that we have been posed. So I'm very optimistic about farming in the future here.
Yeah. So you mentioned like sometimes the farmers they will bring the questions, the problems, and they come to your office trying to find some solutions. Can you provide us any story or like how you helped the farm to
Sure.
solve?
So a lot of times throughout the year, we would have uh, sessions with our different commodity groups, whether it's sugarcane growers, whether it's a rice commodity, whether it's the sweet corn commodity group. And we present some ideas that they may they may want us to do research on. At the same time, the growers may come up with some ideas that they may want us as researchers and specialists to pursue as well. So it is important for us to always have what we call do a needs assessment, where we go and listen to our growers and we identify what is the need. Do they really want us to work on AI in developing a phosphorus sensor, or do they want us to work in trying to identify a cure for a pathogen disease on their sugarcane, or do they want to find some smart fertilizers that can slowly release nitrogen in the soil? So yeah, considering the fact that we also do work in the field of nutrient management, I think that's an area where the growers have shown some interest in discussing to us whether we can work with some biofertilizers or some other type of amendments, soil amendments, other than conventional fertilizers that can be applied in the field. Because one of the problems with conventional fertilizer is that you apply it once, you use it, or you lose it. And so, if we can work with some biofertilizer or some slow release fertilizer, I think those are some promising aspects that I can see in the future.
So talking about the sustainable agriculture, like if we don't properly manage those resources, like if we use a fertilizer, whatever we want, or we just want the productivity, what's gonna happen? What's the cost of
Yeah.
that?
I mean, it's like any resource. You have to think about it. It's not just fertilizer. It's with food. It's with water. It's with any resource. If we are going to use it without proper strategies or without proper management practices, then we could end up in a situation where farmlands end up becoming deserts. So fertile land can become deserts by just over fertilization and having monocultures on them. So we want to be very mindful that we are not going down that route and learning from our past mistakes, where we want to make sure we are growing diverse crops. We want to make sure we are applying fertilizers after soil testing has been done and a recommendation has been provided. We want to make sure our ditches and canals are clean so that we are not transporting excess nutrients to downstream water systems. We want to make sure we don't leave our soils fallow in the fallow period, and we can go ahead with some cover crops in the ground. So we can do crop rotations, right? So these are all different practices that will be beneficial in the long run and maintain that sustainability word in farming.
Yeah. So we also want to ask you some personal insights. For example, you are the student's advisor. You are also an experienced researcher. So do you have any advice for the younger generation of the scientists if they are decided to pursuing the agriculture related
Sure.
research? Yeah.
Yeah. I think being a parent definitely gives a little more appreciation when you interact with students or even graduate students for that matter. Um, you know, I think quality of work is very important. Regardless of what field of area you are pursuing, one of the advice I always give my students is make sure your reference list is has a perfect template and it's not all over the place. Make sure your figures are telling a story, and so make sure you put some time and effort into specifics in your research work, because the audience is going to remember and appreciate that. Uh, so that is one advice I like to give, students of any age, in quality of work rather than just the quantity. It would be great if you have great quality and a lot of quantity, but quality is very important. Another advice I like to give students is always try to look at your results in the rear view mirror, so to speak, because at the moment, at the very moment, you may feel that you are not making any progress, or you may question yourself, why am I doing all this, but always think about it from, let's say, 1 year down the road. Ask yourself, where were you 1 year ago? And have you made some progress since that 12 months? Since
What
those
legacy you left, right?
So that is something there. And at that time, you might say, guess what? I think I got an A in this course. I think I wrote this draft of the paper. I think I completed the experiment that I was struggling with. So I attended a conference or a meeting. So I think I did quite a few things over the duration. So looking at things in the rear view sometimes helps us to ground ourselves and not get too stressed out about the present and the problems of the present.
Once upon a time, you are also a graduate student. Can you give us a funniest story when you were a graduate student, so that we all connect?
Well, yeah, as a professor now, I tell you all students to have a good balance of work and play. But as a graduate student, I had no boundary of what was work or what was play. It was it was all at that very moment, and we would make sure that we studied for our tests and our exams and maintained our good grades. We made sure that our proposals and our paper drafts were delivered on time and of good quality. But at the same time, yeah, our weekends or after hours, we also socialized and tried to have a good balance. So I think, yeah, having that right balance between work and play, even as students at this level, is 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 very, very essential. You don't want to be too much doing one and not the other.
It's been a very good discussion with Dr. Jangu, and I know he's so busy, and I want to thank you for make us time for us, and I hope our audience really like our podcast, and thank you all. Thank you so much. Shua, you want to say something?
Yeah, I think it's a good chance for us to have the communication with the professors to say what's their thoughts, yeah, related to the sustainable agriculture and the phosphorus issues. Yeah.
So goodbye from South Florida, and in I
Thank you.
bye.
Thank you.